All right, some questions to recap what we've been doing here. So here's a first problem. So I'm going to tackle this portion first. Okay? What's there something we can do with the rules that we learned yesterday? Just looking at this, is there one of the rules that we can apply to that situation? Specifically looking at the 2, what else do we know? We could put it there as an exponent, right? So log 4/8 squared. Okay, that's the rule we learned yesterday. Then what? This is log 4/64, right? What is the evaluated value of this expression? So the result is 64. The base was 4, so this is just what your brain is thinking. That's what your brain is thinking about. I need to know that exponent. Did you think 3? That's 3. Okay, so now I still have to do log 9 of all that. So now, what is your brain thinking? What is the exponent that makes that happen? So what is the exponent, base exponent result? What's the exponent that made that happen? That would have a final answer of 1/2. Okay, so I give you 3 questions here. Number 2, separate. Separate using all the rules we learned yesterday.
Could you go back up?
Okay, so here I go. Good? Okay, so I'm going to do the exponent rule. So exponents can become multipliers. So 2 log 5, 9. Multiplication can split apart with an add. So plus log 5y. And then a division can separate with subtraction. And here's where I think you ran into a few in your homework, that this is an x plus 3 unit. You can't separate it. Does that make sense? It wasn't with multiplication, it wasn't with division, so you can't separate it. Okay? So that's why I wanted to do that one. Okay, number 3, log 6/36 plus log 6/24 minus log 6/4. I want you to evaluate. That would be my question. Evaluate this. Okay, so here's my suggestion. When I look at this, I see it all separated. So I'm thinking I want to put it back together with the rules. So log 6 of, and I'm thinking, how could I put those separated statements back together? So what do you think? There was something plus something, subtract. So how does it go back together? So 36 will be on a top. 24 would be times on the top. And 4 would be a divide. Okay, so now you can work that out. And I think if you're in your calculator, that's fine, that's 216. So what does this evaluate to? What's the final answer then? So your brain is thinking, what's the exponent? What's the exponent that made that happen? Okay, because 6 cubed is 216. Okay, so I'll have a couple of questions like that probably on your test that make you think about all your rearranging stuff and evaluating as well, right? Okay, today is the day to find out if you really truly like your calculator or not. Does anybody still have a backwards calculator? Like when you push sine 30, do you do that or do you do 30 sine? Do you have a backwards? You might really hate your calculator today. If you figure it out, great. If you want to quit, ask me for one of mine. Do you or not?
No,
yours is forward. Okay.
Yeah, that's how I guess. Okay.
Okay, so using all the stuff we've learned, we're going to learn how to solve equations. Okay, so what's your first instinct when you see something like this where there's log 4s separated? What do you think we want to do? Put them together. So log 4 so those two separated log 4s I'm going to put together as one. So they were separated with addition. So now I'm going to times the two units together. Okay, obviously brackets are important, right? Okay, can you take this, which is in log form, can you rearrange it for me into exponential form? Think, what's the base to the exponent equals the result? Can you maneuver that for me? Base of 4 to the 2 equals result. Right? Base, result, exponent. Those are your components, right? Remembering where they are. Okay, so I'm going to work to simplify some stuff here. So 16 equals 10x minus x squared. Okay, what would you want to do in math with something that looks like that? When you have x squareds and x is involved, 0 on one side. You all know that I hate negatives with the leaders, so I'm going to move everything to that side. So positive x squared, subtract 10x plus 16 equals 0. It does factor. Okay, now here's the thing. At the very end of these, you have to check your answer because when you're working with logs, the result has to be positive. So for instance, if I was to think about x as an 8, okay, that's positive. 10 subtract 8 is positive. So it's good. If x was 2, this would be a 2, and this would be 10 subtract 2, positive. So it's also good.
It's okay that it's here.
Okay, but you'll see some that don't work out, and that's why. Because this result always has to be positive. Okay, now we're going to introduce something you've never done before. We now officially have a variable located in the exponent spot. You have never in all of your schooling ever solved for an exponent variable. So now we have the tools to do it. Okay, so what I'm going to do is I'm going to log both sides. So I log both sides. Okay, we know rules. What do we know about rules? This is an exponent. Where can we move exponents? To the multiplier, I'm going to call it a coefficient. And I have to have brackets on that. That's important there. And any rules I could apply onto the right side? Yep, I can move, again, I can move the exponent to the multiplier. Okay, so on the left side here, I'm going to have to distribute with brackets there. So can you work that out? So 3x log 7 plus 1 log 7. Okay, so here's my suggestion. When we're getting to this stage, anything that deals with an x, I'm going to have on one side. Anything that doesn't have an x goes to the opposite side. So I'm going to keep this term, and then I'm going to move that. And now, how do I isolate x? I have to divide by 3 log 7. Okay, here's the big thing. How are we going to type this in? Okay, so I need you to make sure you put the brackets on the top. So this, subtract this in brackets, divided by that. Okay, so it's all about, can we do this in our calculator? Some of your calculators probably have extra brackets, so make sure you're doing the right amount of brackets. And if you're not getting it, tell me to come over. Anybody match mine at least?
Yeah.
So then you would have to put 10. Does everybody know that when I have my log, there's a secret base of 10 on that as well, right?
Let's see what it is.
Everybody see how that backwards? Yeah. Oh, wait, we need to probably do 2 problems. You did it? Okay.
It's just so much nicer.
I think
So
you got it? Okay. Anybody? Button more? This is good? Okay. Ready? Let's try the one. Let's go below it. We don't need to do all of these. Okay, so I have exponents that have variables. So I'm going to log both sides. I'm going to log both sides. Okay, you ready? The rules. I had something connected with multiplication. So I'm going to split log 5 plus, so multiplication splits with add, and I'm also going to move the exponent to the front. Are we okay to see the rules? The multiplication splits add, exponents become coefficients. Is that okay? Looks good with the rules? So on the right-hand side, exponents become multiplier coefficients. Okay, so that was the rules part of it. Now here, you're going to want to distribute that. Okay, so all the time when you see a binomial exponent, make sure there's brackets on it. Okay, so when I look at it, I'm going to say everything x one side, everything without x is the other side. So I think for me that would mean the best option would be to move that term. Okay, now because I have all the x stuff on one side, I'm actually going to GCF an x out. So pull a x out of all the terms. And again, I guess the left side, if you want to keep writing it, keeps following as well. Okay, now how do I get x alone? I have to divide okay. It looks complicated, but it's just all about following lots of the rules and order. So, okay, let's practice the typing. That's the hard part. So make sure I would put brackets on that stuff. Let's see if we can all get to the same spot here. Anybody that matches me, let me know with the thumbs up so I know that I'm good. And we're back to like making sure we're rounding to 3 decimals. Okay, again, if you are feeling like you really don't like your calculator, maybe because it's doing all the brackets, this white one is the most user-friendly one with the log stuff if anybody feels like they want to try it out.
We weren't even doing X's yet. We were doing fractions. We were doing fractions.
Okay, I'm gonna do the last one here, sorry. I'm just gonna skip some. They just are kind of long too.
Yeah.
Okay, so here's the difference on the last example. Instead of logging both sides, I'm going to natural log both sides. ln means the natural log. And why did I pick that? Because natural log uses a base of e. And if I saw an e, well, I'm going to natural log it. Okay, so this was just to remember when you do an ln. So if I had ln of x, the same thing would be to do the log e, base e. ln just uses log e. Okay. So here's the rules. Ready? Exponents become coefficients. Okay, now I'm going to tell you why I picked ln instead of log. Okay, it's not wrong if you do log. You're going to get to the same spot. But here's why I picked ln, because the ln of e is, does anybody know? Think about the ln of e is the same as writing log e, e. What is the exponent? What would be the exponent that makes this happen? 1. Okay? So if this is 1, is that okay if I just do that? If it's 1, I don't need to times it by that, right? Okay, if you had done log e, you would have been FOILing or distributing and doing a bunch of steps. Not wrong, but you would have way more steps. Okay, so now I'm going to move non-x stuff. So anything with an x was one side, anything without an x went to the other side. And now I'm going to divide by 5. So that is what we're going to have to practice typing in. So you need to find your ln button.